Split and open up to the My Notre Dame page. So once you've got to the My Notre Dame page and clicked on our class, under the links, there's the Delta Math registration. We did this a little bit first semester if you had me. We didn't do it very often, but all the classes got shuffled, so we need to do a re-register so that you're in the right sections. So you just click on the link. It'll already have the code inputted. All you have to do is register with Google and pick your school email account and you're done. Takes like 3 seconds. We're not doing anything else with it today. Just wanted to do the registration and get that out of the way. Cool? And here I'll go even look at my end and watch this populate for me. So what I want to look at. That's it. Ooh, 7 people already in. Refresh again. Ooh, to 15. Good job, guys. Ooh, to 16. How many people do I have? 2, 4, 8, 14, 20. Next thing we're going to do is going to be using Microsoft Teams. So if you've completed your registration for Delta Math, go ahead and open up your Microsoft Teams. Now I had 2 options on my computer all of a sudden. I don't remember why I have 2 options, but I picked the work or school one. If you just pick the first one, I don't think it's like a big hassle or whatever, and it doesn't know what to do with it. So once you've finished your Delta Math registration, which again should have been real quick, just a couple of seconds to click the link and then register with Google or whatever, you're going to open up Microsoft Teams. When you open up Microsoft Teams, you should have a 5th hour pre-calc tile. Is anyone missing the 5th hour pre-calc tile? I tried to manually preload everybody beforehand so it goes a little quicker, but every year it seems like I manage to miss 1 or 2 names, or there's somebody late schedule change or whatever. Okay. So go ahead and click on the tile. And then from this navigation window here on the left, you're going to click the class notebook option. That'll load in a display of OneNote here on the right. From that OneNote display, you're going to find the Open in Browser dropdown and pick Open in Desktop App. And that should then link your OneNote with the shared OneNote page that I've built for you already. And assuming that everything was preloaded, it went real quick, and it should just been a second or 2 delay to have that stuff load in. If I don't do it in advance, it takes like, depending on how fast the internet's feeling like, it could be like 20 or 30 minutes for the OneNote to load in, which is just unacceptable, right? It's too slow. So if you've been in my class first semester, you kind of know the routine here, but if you're new to this class, most of everything I do is going to be done inside of OneNote. So when you open up your OneNote, you're going to see four like tabs at the top. Collaboration space, we don't use that. Content library, that's where I'm going to warehouse like all of the things that I would share with you, whether it's assignments or notes or the problem sets or the book pages or whatever. All will go there in the content library. And then you'll have one for your name. And then inside of that, I have two tabs for you, one for notes and one for the homeworks. So I'm going to check all of our homework assignments that I give through OneNote. We'll talk about how to get stuff in there a little bit later, but if you're unsure, just ask somebody that was in here first semester and they can give you the skinny as to like how to do that. We had a lot of practice first semester, so everybody that had me first semester is already kind of an expert to some degree anyways. So I'm going to look in the content library here first and just kind of talk about the syllabus just briefly. I'm just going to hit on a couple of main points because the syllabus for second semester is almost identical to the first semester syllabus. The only thing that changed was the content we're covering. So if you are new this semester to my class, maybe give it a read through at your leisure, but it's the same percentage breakdowns for tests, homework, quizzes, homeworks, and exams. The homework is still going to be checked weekly. Sunday at midnight will be when it's due in the OneNote. Obviously, I don't check it Sunday at midnight. I'm not sitting at midnight going, oh, homework to grade. I am sleeping in my bed, but I have to pick a due date, and that's just what I pick. As long as it's there by the time I check, Monday, whenever I get around to it, you're fine. So if it's like, oh no, it's 12:54, and I just now finished, it's fine. Not a big deal. The late assignment policy for the school, typically, like if you have a late assignment, I don't give you any penalty for it. Homework quizzes, we typically do one homework quiz per chapter. These are unannounced and they're based on recent homeworks and their closed book. I grade them on a 10-point scale just on overall demonstration of understanding. As anybody can from first semester will tell you, it's like, yeah, I got everything wrong and I got a 7 or an 8 or whatever. It's just like, if you do stuff that's kind of right, you get most of the points out of it. Now you have to get, to get the 10, you have to basically do everything right. But there's that, I don't know, dress code, computer use, whatever, that's all normal stuff. At the end of the semester, we'll drop a low homework score, a low quiz grade, and then give you the option to take a double test score or to do a retake of some other test where we cap that retake at 85. And then this is the list of stuff that we're covering this semester. Up through chapter 11 is still kind of new-ish, but after that, these are like chapters 12, 13, 14, 15 are kind of revisiting topics from Algebra 2, so it's should feel pretty familiar at that point. Morning. Good morning. How are you?
Good. How are you?
Doing fine.
Happy New Year.
Happy New Year. Grace for you. You're welcome. I would say that in general, second semester is a little bit easier than first semester. Although I think the single hardest topic we do in the course is in second semester. Second semester becomes very repetitive because it's kind of like the same skills over and over and over with just like a different name attached to it. And then the second half of the course is kind of revisiting things from Algebra 2 that should be pretty familiar. So, the 2D and 3D vectors is the tough one. But the parametric and polar is almost identical. And the complex number is almost identical technique-wise. So like the things you develop in that chapter just kind of get reused over and over again. But that's the chapter 8 is the one that's the tough one typically. Just as a heads up. If you were in this course or if you had me first semester, I don't need you to do this again. But if you're new to me, second semester, so like Jacob, Elena, already Lucent, Joey, Hannah, etc. Just fill out, and have this signed up for me. Yeah, sometime next week is fine. You can give me a physical copy, or you can do it digitally and just drop it into your OneNote. Either is okay. If you forget, I'll remind you again. But it's not, not a big rush. Sometime next week is perfect. Cool. Okay. Well, that being said, let's go ahead and kind of get started here with chapter 7. So as I said earlier, really everything I'm going to do is going to be run through OneNote. So the notes that I'm going to do here for you guys is going to be inside of OneNote. And I'm going to do them inside the content library, which means you have access to them basically immediately as soon as the OneNote sync. So you're welcome to take your notes in any way you see fit. So some people like to take a physical copy of notes, writing things down and actively participating helps. Some of us do that in a notebook. Some of us like to do it inside of OneNote. Some of us like to sit and listen and he's writing it all down for me anyways. I have access to it. I'm just going to sit and listen and pay attention because that works better for me. I encourage you to do what works best for you. I'm not going to micromanage what you're doing here. In fact, I would encourage you to, experiment and kind of find what works best for you, whether it's I'm going to just kind of follow along, take some brief notes, and then really sit and listen a lot, or it's no, I'm going to write down every single thing and be a maniac about it. Whatever you need to do, yourself. It's important that you've kind of figured out, or that you take some time to figure out what works best for you. All right. So chapter 7 is, I think, a pretty easy chapter in general. So we remember from first semester and even back into geometry, we would ask you guys to solve a triangle. And what that meant is to find all the side lengths and angle measures for that triangle. And if we had a right triangle, this is pretty easy, right? For a right triangle, all you need is SOHCAHTOA and the Pythagorean theorem, and you're pretty much good to go. Everybody kind of remember doing that in first semester and/or geometry? Now, what happens if we don't have a right triangle? What could we do there? Well, most of the triangles we encounter are non-right triangles. So really should have, what's going on here? Okay. Really need to develop a method to cope with that because, well, it can surely happen a lot. So let's say we just have some generic non-right triangle. Since it's a non-right triangle, SOHCAHTOA's out, Pythagorean theorem's out, can't use those tools, they're not applicable. What can we do? Well, the answer is we kind of cheat, right? So what I would do is I'm going to start by drawing in an altitude And it doesn't really matter which place I draw this altitude from. I'm going to draw my altitude from vertex C. So I'm just going to draw in a line that intersects vertex C and is perpendicular to the side opposite. And I'm going to call that side length H. So in doing this, what I've done is I created two right triangles. And by creating two right triangles, what I've allowed myself to do is use SOHCAHTOA, the Pythagorean theorem, inside of those right triangles. So if I look at the yellow triangle, I could say something like sine A is equal to opposite over hypotenuse. And inside the green triangle, I could say something like sine B is equal to opposite over hypotenuse. And what I like here in doing this is I notice that, hey, both of these two equations contain that value H. So what I'm going to do is I'm going to treat this like a system of two equations, set each of them equal to H, so I can set them equal to each other. So I'll multiply both sides by B in my first equation, and multiply both sides by A in the second equation. And because both of these two now are equal to H, I can set them equal to each other. And what I have now is an equation that's true inside of a right triangle that depends only on the side lengths and angle measures in that non-right triangle, right? Which is wonderful. So conventionally, this is not how we would write this equation. So to get to the kind of the standard representation, I'm going to divide both sides by AB. So the B's would cancel, and then the A's would cancel. And this is the kind of the traditional representation of this, where we have the angle and the side opposite that angle inside of the same fraction. Now to complete this, what I would do then is I would just repeat the process. So I draw in another altitude, either from A or B, it doesn't really matter. So I could do this, repeat the process again, and all that's going to do is get me that this is also equal to, shockingly, sine C over C. I assume most of us would have guessed that was coming. Now, this equation that we've written here, or series of equations, is referred to as the law of sines. And I abbreviate law of sines as LOS because I write it a lot and I'm efficient. So let's just take a quick look at an example or two of using the law of sines to solve a non-right triangle. As an aside, could I use the law of sines on a right triangle? Yeah, it still works. Is it like silly to do that and kind of overcomplicating a problem that's easier than that is? Yeah, but it's not. It wouldn't be wrong. You could still do it. And that's usually what we're looking for inside of mathematics, is when we generalize something, we want it to still cover everything that we could do before, even if it's not easier than the way we're doing it, we still need to work. Okay. So let's take a look at this problem here. It says in a triangle, angle A is 32 degrees, angle B is 73 degrees, and side C is 13 inches. And we're asked to solve the triangle. So that means we need to find the value for angle C, for side A, and for side B. Everybody's cool with what we're looking for? All right. I would start by drawing myself a picture here. And when I draw myself a picture, I never worry about the scale. So I don't care, like, well, maybe I would draw it here. But I'm not really worried about like whether the 32-degree angle is in the picture looks bigger than the 73-degree angle. I don't really care. It's just for my own peace of mind. I have to be careful when I'm labeling my side lengths though, right? The way we constructed the law of sines was very specific in that the side length that's opposite the angle needs to be named with the same letter. So this side has to be A because it's opposite angle A. This side has to be B because it's opposite angle B. This side has to be C because it's opposite angle C. If you don't name them that way, the law of sines will not work. So it's really important that we're using that same naming convention. And now I'm just going to write in the givens. Everybody cool there? All right, what do you want to find first? Angle C, side A, or side B? There is a correct answer for this one. Carmen? Yeah, angle C. So to use the law of sines, what you'll notice is that you need to have an angle on the side opposite it. We don't have that for A. We don't have that for B. And we don't have that for C. But it is really pretty easy to find the value for angle C. How would I go about doing that? Yeah, I know that the interior angles of a triangle add to be 180. So I can just do 180 minus angle A minus angle B. What's that? 105, so that should be 75 then. And I'll go ahead and once I've found one of these values, I'll write it in, and I'll use a different color there to show that it wasn't given information, that I actually found that. Everybody happy here? Okay. Now that I know angle C and side C, I can use that to solve for either side A or side B. Does it matter the order in which I do that? Not here, no. Later, for some of the other things, the order will matter, but not with the law of sines in this particular case. So I'll start by writing sine C over C is equal to sine A over A. And I'm just going to choose to find side A first because it's the alphabet. All right. I don't have a good reason, just alphabetical. So this type of an equation where you have one fraction equal to another fraction was called a proportion. Do you remember from geometry? You solved a lot of these. How do you solve a proportion? Cross multiply and divide, right? Remember, cross multiplication is not a multiplication technique. It's a solving technique. We use cross multiplication to solve a proportion. So we multiply and set it equal to the other product. That all look familiar? So that's my cross multiplication. Now I just need to divide to get the a by itself. So what am I going to divide by? Sine 75. Very good. And I'm trying to remember here, it's been a while since I've taught the course. In honors geometry, do you guys do law of sines? I think you do for a minute. It's probably pretty quick. But if this looks familiar, I think you do it. I don't think you do it for very long or in very much depth. It might just be like one section of a like one little set of problems inside of a bigger chapter or whatever. But I think you do it. All right, so it's calculator time now. Before I start typing this into my calculator, what should I check? Yeah, I need to check my mode because I'm about to use sine, cosine, and tangent, and I probably haven't cracked my calculator in 3 weeks. Who knows what mode it was in? I should be in degree mode. Mine is, but if you're following along, you should go ahead and check yours. How do we know we needed degree mode here? Because the angles were given in degrees. Exactly, yes. All right, so I'll just type this into my calculator. I like to use the fraction command so I can type it in my calculator exactly like it looks on my sheet of paper. So I do alpha y equals and then choose the first option. That'll get me the fraction bar. And I like to use that just because it makes it harder to make like a parentheses order of operations mistake when typing it into my calculator. So I'll just type it in exactly as it looks. And I get 713 or thereabouts. I think my lengths in this problem are given in inches, so that'll be inches because it's a side length. Everybody happy here? All right, I have 2 of the 3 side lengths. To find the third one, I can just use the Pythagorean theorem, right? No!
Oh, wait.
It's not a right triangle. What do I have to do? I have to do the law of sines again. Now, technically at this point, I could use angle C and side C, or I could use angle A and side A. Which one is Mr. Kulik going to choose to do? C. Why? I used it before, but there is a reason why I'm not going to use A. C is not rounded exactly right. Now, for what we're doing, is it going to make a difference if I'm using something rounded to 2 decimal points or not? Probably not. But if you're trying to land a rocket ship on the moon, do you want to avoid a rounded answer? Yeah, if you can. Right? Absolutely. So again, you could use sine A over A instead of sine C over C as your other part, but in general, I'm always going to take a non-rounded option versus a rounded one, just to be a little bit more accurate. So I'll go ahead and I'll do my cross multiplication. And then I'll divide by sine 75. And I'm not going to show the step this time. I'm just going to say it aloud verbally because, well, should be pretty clear as to what I did there. And then it's calculator time. So I get 1287 there. Feel good there? Pretty easy, right? Not a big deal. Basically, I'm just grinding away with a formula that's not that hard to use. Probably the most likely place you'd make a mistake is you try to use a right triangle technique on something, or you just drew your picture wrong and labeled the sides wrong or something. But pretty tough to make too much of a mess out of this. Hi, how are you?
Good, how are you?
Good. Elena, it's for you. You're welcome. All right. So we start the same way, right? Draw our picture. So I have side or angle P, angle Q, and what do you think I'm going to choose as my third angle? R. Not because I love pirates, but just because of the alphabet. Does it really matter what you called it? No, not really. So just go ahead and label. Now here you notice, solving this triangle, we're looking for R, P, or angle R, side P, and then side R. You might notice here that in this one, I could start with any of these, right? Well, almost any of them. I couldn't find side R right away, but I could find angle R, or I could find side P first. Either of those two would be reasonable to do first. Does it matter which one I do first? Which one do you think I'm going to do first? Angle R, because it's so easy. Yeah, that's what I would do first, but it does not matter. What is that? 57, I think. Okay. And now to solve for side P or side R, I could do either one of them. It doesn't matter the order in which I do them. Which one do you suppose I'm going to do first? P, just because it's the alphabet. I don't have a good reason. So we cross multiply and divide. I'm just going to do that all in one step. Does anybody object to that? I'm just kind of streamlining, showing the work here. Everybody's cool? We've done it a bunch of times now. The algebra is not very complicated. We do it over and over and over again. I am totally okay with going straight to, showing this and then going straight to that. That's totally reasonable for students at this level. So we got 506 there. And what do we have? Centimeters in this problem, I think. And then we'll just repeat the same process. So again, I'm going to use angle Q and side Q that are not rounded. I could use angle P and side P if I were so inclined. It's not wrong to do that, but I'm not going to. Just because I don't have to deal with a rounded answer. And I'll just do it again, type her in. So there I get 622-ish. So far, so good. All right, let's think back here to our geometry class. And let's try to remember our triangle congruence theorems. So typically these were named with an acronym, a like 3-letter acronym. Does anybody remember, Elena? Yeah, that was one of them. What else do we have?
Side,
Well, that
side
side is one. Yup.
Is there angle, side?
Angle side is one. There's 5. Angle is for similarity, not congruence, though. But that was a thing. Angle side angle. Mm-hmm. And then the 5th one is only 2 letters. It was that hypotenuse leg theorem, which is a special case of that SSA situation. And the special case being the A has to be 90 degrees. So these are the 5 situations that we can also solve a non-right triangle in. So this would be the given information that we can use. These guys are law of sine situations. In fact, our previous 2 examples were these 2. Let's go back and look and see if we can decide which one was which. So if we go back to the first example, I'll erase this thing. Which one was this? Was this angle side angle or angle side? It is not angle side. Well, we don't have 2 sides. This is angle side angle. Yeah. And the reason I can tell is because I notice the side length is an arm in both angles, right? The given side length is a part of both of those angles, right? If I draw angle A and then I draw angle B, I notice that the given side C is part of both of those angles. That's what angle side angle is going to look like. Everybody okay with that? Let's go look at our second example here. Which one is this? This is angle side. Notice if we look at the arms of angle Q, neither one of those involve side Q, right? That's how I know immediately this is angle side. Everybody's cool with how to identify that? And I'm just using my eyes. There's no other better way to do it than just kind of looking at your picture. Cool? Okay. Now, these 2 are going to be law of cosine situations. We'll talk about those when we talk about the law of cosines. This is also a law of sine situation, but it is quite a bit trickier than the previous ones because the SSA situation does not guarantee triangle congruence. What does that mean? If I give you just 2 sides in an angle in an SSA formation, we might have an impossible situation where there's no triangle that can possibly be formed with that. You might be able to make 1 triangle with that, or you might be able to make 2 distinct triangles from this. So this is going to involve a little bit more detail in how do I sort out which one of these 3 situations I'm going to be encountering just by looking at the given information from my side. And in fact, in one of the situations, depending on the measurements you're given, you can't even tell immediately just from the given information. You have to do further calculation to figure out what's going on. So let's look at that, and this is section 7.2. Because you can't immediately tell, we call that the ambiguous case. So that's just looking at these SSA situations. So actually, let's start by doing this first. So just want to refresh our memories about this SSA situation, that we does not guarantee triangle congruence. So I noticed there that triangle ACD is clearly not congruent to triangle BCD, right? Everybody should have no arguments there, correct? However, we have an SSA situation in triangle ACD. We have the corresponding parts are congruent in a SSA configuration. Right? We have the SSA parts are congruent, but the triangles are not necessarily congruent. Everybody's okay with that? So this makes our lives a little bit complicated. So to determine what's going on, for the most part, we can just look at the given information. So the first thing we're going to look at is if angle A is not acute. Okay. So if angle A is not acute, what kind of triangle do we have? Obtuse or a right. Okay. In that situation, how many obtuse or right angles can a triangle have? Exactly one. I know that across from the biggest angle should be the biggest side, right? So if I have an obtuse angle at A and the side opposite A, BC, is not the biggest side, what does that tell me? That something impossible is going on. You can't make a triangle where the hypotenuse is not the longest side. Everybody agree with that? If we look at the picture we drew there with angle A, BC is the hypotenuse. If BC is not longer than every other side, then that's not possible to do that. Can't have a triangle. Everybody cool? Now, if BC is the longest side, there's no problem. Just one triangle can be created. So that's not too bad, right? Pretty clear as to what's going on. If you have an obtuse angle in your SSA situation, you just have to look to make sure that the hypotenuse is indeed the longest side. If it is, just proceed with your law of sines as normal. If it's not, then it's just an impossible problem. You just say not possible or no triangle possible, whatever. Everybody cool? Okay. Well, that doesn't seem so hard, Mr. Kulik. Yeah, but that's because that's the easy situation. So the next situation we'll look at is if that angle A is acute. And that So if we have an acute angle and the side opposite is at least as big as the other side given, that's fine. Just a one triangle situation. But if it is the shorter side, we can't say anything about how many triangles are formed immediately. This is what we refer to specifically as the ambiguous case. Is when we have an SSA situation, the angle is acute, and the side opposite the angle, the acute opposite the acute angle is the shorter of the two given sides. So what do we, I mean, we have to be able to figure that out eventually. What do we need to do? So let's look at this situation. Again, I'm going to start by just drawing myself a picture. And then labeling my picture. So first thing I want to do is determine whether what situation this is, because I have two sides and angle. Is this SSA or is this side angle side? Is the angle between the two sides that are given? Nope. So this is SSA. The given angle is acute, and the side opposite that given angle is shorter than the other given side. So this is the ambiguous case. Everybody's cool with how I've determined that? Okay. So the way to figure out whether we have 0, 1, or 2 triangles is I'm going to just use the law of sines. So I'm going to set this up as I would just any regular old law of sines problem. So I'm going to do sine B over B equals sine A over A. And I'm going to solve for sine A. So I cross multiply and divide. And this number is going to tell me what's going on. So let's think back a little bit about what we know about sine of an angle. So let's go back to first semester. What's the largest possible value that sine can give us? 1. So if this number is greater than 1, that means something impossible is happening and no triangle can be formed. When sine equals 1, what angle is that? That's a right angle. That's our hypotenuse leg situation, which guarantees us only one triangle. So what's going to happen if we're less than 1? Yeah, that's where we can end up with 2. So let's go ahead and compute 12 sine 48 divided by 10 and see which one we fall into. So I have 0.892. So which one do we have? We got 2. Okay, so let's find both sets of answers now. In my experience, this is the single hardest thing we do in this chapter. And it's mostly hard because of organizational reasons. So I'm going to try to be super clear about organizing my work so that I can remember which answers go to which triangle and not make any goof ups. So there's 3 things I need to find. I need to find angle A. I need to find side B and angle B. No, sorry, side C and angle C, right? Yeah. Now, because I have to do that in each triangle, I'm going to add a subscript so I can differentiate my work from one triangle to the other. Everybody's cool with that? So I'm going to start triangle 1. And what I'm going to start with is just that equation. How do I solve that equation for angle A? Braden, what was that? Yeah, where you sine inverse. Very good. So I'll just go to my calculator and do sine inverse. So second, sine inverse. And then I'm going to use that previous answer, which is all the decimal places, because I'm a maniac and want that extra bit of accuracy. So I get like 63.10. Now that I have angle A, angle C is trivial, right? How would I find angle C? Yeah, I know there's 180 degrees in the triangle. So I can just subtract the other 2 angles from 180, and that'll be that. So that gives me 68.90. And now that I have angle C, I can set up my law of cosines. And I'm forced to use this rounded answer. There's no way around it, and that's okay. Just double check that that 10 was the right angle, or side length. It is. Okay. And then I can just cross multiply and divide. And I got my first set of answers. So 1255. So far, so good. Not a big deal, right? second set of answers is actually a little bit easier to come up with than the first set, because that second angle, or angle A2, always has to be the supplement of angle A1. So that first angle that we found in triangle 1, the first angle we find in triangle 2 is just going to be the supplement of it. Let's see this guy. So 116.90. Note for C2, we are not going to be looking at the supplement of C1. Rather, we're just going to be using that triangle sum theorem. Everybody okay there? So this is easier so far because I haven't had to use the law of sines yet, right? So 1510. And then to find side C, I'll do that the same way. So sine B over B equals sine of my angle C, my new angle C, my angle C2. Should have probably put subscripts on that C1 over there. But we're just still doing the same thing. We're cross multiplying and dividing. So I just grind that through my calculator, and I'm donezos. What do you guys think? So far, so good? This is where we're stopping today. I think at this point you guys can do up through 14 in the problem set. So 350. Just double check that right now. Yes. Nothing is due on Sunday. So our first problem set will be next, not this Sunday, but the following Sunday. So what is that going to be? Like the 13th or something? 15th. If the side opposite the acute angle is the shorter side.
Good morning,
which in words is often easier to think about than letters.
At the end of this period, in about